Okay, so here we're going to look at some harder problems involving arcs and sectors. And we've already seen a sector is just a bit of pie. It's like you cut a bit of pizza out or a bit of cake out. That's a sector. We've got a radius, and this we call the arc. So anything around the circumference of a circle we call an arc. One thing later on that we'll see is actually if you draw a line across the end of a sector from one end to the other, then this little bit here is what we call a segment. A segment. I always like to remember it as Terry's chocolate orange segment. Just look like that, a big ball of those. Great. So, the kind of question we've been looking at is we've been given a radius and asked to find the arc length. And this slightly harder one is we're actually given the arc length of this sector and we're asked to find the radius. Now I say it's slightly harder because it's not too much different from what we want to do before. Every time we know that we're dealing with an arc length, then we just write down the arc length formula. And we saw that the arc length is, well, it's a fraction of the circle, whatever fraction of the circle we're talking about. So, and the way that we've written that before is theta out of 360, whatever angle out of 360 degrees. And we're multiplying that by pi d, by the circumference. So what we have here is a fraction of the circumference. And we know that the arc is a fraction of the circumference. It's part of the whole distance around the outside of the circle. Now, apart from that, guys, all we have to do is fill this in. So the arc length here is 20. The angle here is 24 degrees. So the fraction it makes is 24 out of 360. And we're multiplying that by pi and pi d. Okay. Now, I'm going to go through this in doing it in number stages. You can, if you wanted, you could just work out what 24 out of 360 divided by 360 times pi was, okay, and then work that way. I'm going to do it slightly longer and say, okay, instead of dividing the right by 360, I'm going to multiply the left by 360, and that would equal 24 pi d. And then to find d, we're going to do 20 times 360, but instead of multiplying the right by 24 pi, we're going to take it across and divide the left by 24 pi. And actually, we can write it in our calculators just like this. You can write it like a fraction, 20 times 360 over 24 pi. And when you do that, we should get an answer of, I think, 95.49 centimeters. Now, one final thing here is looking at the question, we were actually asked for the radius of this sector. And what we have found is we found the diameter, which is great. But we should know that the radius is just half the diameter. So it's 95.49 divided by 2. And I'm just going to give that to one decimal place here. So that's 47.7 centimeters. So although there's a wee bit more rearranging skills needed here, that's fine. We start by writing down our formula and just filling it in. And in math, so much is like that. If you've got a formula, fill it in, and then you can work from there. As I said, the other thing that possibly we could have done is, if we'd wanted, we could have said, okay, 20 is equal to, well, if I do 24 divided by 360, and then multiply that by pi, we could say that's 0.209 4 d. You can just work out what that bit is, and then d would be 20 divided by 0.2094. And again, when you put that into your calculator, we get 95.49. Yeah, it's just a slightly different way of doing it. Just this 24 divided by 360 times pi, just you can work that out as well. And sometimes you might find that a wee bit easier. Okay, either way is fine. I think this question is back to some of the easier stuff, but we just need to be a little bit careful. because in it we're asked to find the perimeter of this shape. So the first thing we need to do, is work out the arc length. And this is the major sector, so I guess we could call this a major arc. And the arc length is whatever fraction, so theta over 360, of the circumference, pi d. So to get the arc length here, the angle we're dealing with is 303 degrees out of 360. So the fraction is 303 out of 360. And we're multiplying that by pi, and we're multiplying by the diameter. Now just be careful again, 23 centimeters is the radius, so the diameter is twice that, so it's 46 centimeters. And when you put that into your calculator, guys, you get 121.63 centimeters. However, just be careful. We're asked for the perimeter of the shape. And the perimeter is not just the arc length. Don't forget, the perimeter is the distance round the whole of the shape. So the perimeter here takes into account the arc length, but also these two bits here. So when I want to find the perimeter, I just start a new line. P equals, well, it's the arc length plus these two wee extra bits. And these two wee extra bits are just radii. So plus 23 plus 23. And again, that's 167.6 centimeters to one decimal place. Okay, so I just need to make sure that I include these two wee extra bits as well as the arc length. So find the arc length first and add on the two wee extra bits. Okay, that one's a bit easier, a bit more like what we were doing on Monday, but just need to be careful to add on the extra bits. Guys, the last bit here, and this is find the area of the unshaded segment. So the segment is here, this bit here. It's like I say, we have a sector and we cut off from one side to the other. So we're left with a triangle and this segment, a segment. And so what I want to do then is to find the area of that. Now there's a little bit of trigonometry in this, which you have seen last year, but I'm just going to quickly go through it. Because if we want to find the area of the triangle, we firstly need to find this height. And we also need to find this length here. Let's call it x. Now, to do that, to find the height, what I'm just going to do is look at that triangle. It's a right angled triangle. And the angle at the top here is half. It splits it bang in half. So this is 47 degrees for me. And I know the radius is 9 centimeters. So if I want to work out, say this value x, what I'm going to do is I know the opposite side and the hypotenuse. So I'm going to use sine of theta is equal to the opposite over the hypotenuse. Now, again, we will be looking at this later in the year or start next year, so don't worry too much if you don't remember it too much. But simply, we get that sine of, fill the angle in, sine of 47 is equal to the opposite, which I'm calling x, divided by the radius 9. And so 9 sine 47 is equal to x. So to get this distance, we take the radius and we multiply it. This radius, we multiply it by the sine of whatever angle we have here. So this angle is 47 degrees. Likewise, if we want to find the height of that triangle, h, it's the same sort of process, but we're going to use cosine because cosine theta is adjacent over hypotenuse. Now again, if you don't quite remember all that, don't worry. It's this last line that is going to help you today. So let's fill that in. Cosine of 47 degrees is the adjacent, whatever we're calling that, the height, over 9. And so 9 cos 47 is equal to this height. So this height here is equal to whatever length the radius is times the cosine of 47. Okay, so in this case, you'll use cosine to find the height, and you're going to use sine to find the length. Now finally, to get the area of the triangle. Area of the triangle is a half the base. Okay, and when we work that base out, 9 sine 47 is 6.58 centimeters. So it's a half the base, 6.58 centimeters, multiplied by the height. And when we work the height out, we get 9 cos 47 is 6.14. 6.14. And that'll get us the area of this right-hand triangle. Now the left-hand triangle is exactly the same. So to get the total area of the triangle, I'm just going to double it. And that works out as, I think, 40.40. Okay, so getting that triangle, a wee bit of work to it, but hopefully you can follow just that little example there. And you're just changing for these two numbers, the radius and the angle. The radius and the angle. Now, I want to find what's the area of the sector. And we have this formula from Monday. So this is theta over 360. It's whatever fraction of the circle we're talking about, multiplied by the area of the circle. Now here, when we talk about the whole sector, the angle at the middle is 94 degrees. So the fraction is 94 out of 360. We're multiplying that by pi and by the radius squared. And thankfully we can just plug that all into our calculator and we get 66.44. So finally, the segment area, which is this bit down here, is simply 66.44, the area of the total area, minus the area of the triangle, 40.4. And when we do that, we get, in this case, it is 25.96. Or if we're asked to one decimal place, oops, sorry, it's 25. I'm going to delete that. That's too messy. Excuse me. So that's 25.96 or 26.0 to one decimal place. Okay. There's quite a wee bit in that, just trying to find the area of the triangle. So just be a wee bit careful with that. If you're not sure, you can always still find the area of the sector, because that's what we were doing on our last lesson. Okay.